Hello students, now I am going to do problems in a type 4 in the module 1 complex variable 1 in the subject complex analysis, probability and statistical methods. So before going to do the problems in type 4, so here the type 4 problems, it is like a mixed type of problems. So different types of problems we can observe here. So we'll do few problems in a type 4. So first problem will be like this. Find the analytic function f of z equals to u plus iv given u minus v equals to e to the power x cos y minus sin y. So here we have to find out the analytic function f of z. We have to find out. Given equation is u minus v. They given in terms of x and y. Okay, the given u minus v, which is equals to e power x cos y minus sin y, you just write as it is. Do the differentiation is with respect to x partially, so that this equation can be written as ux minus vx, which is equals to e to the power x cos y minus sin y. You just take this as equation number 1. Do the differentiation of the same equation with respect to y partially. We can write uy minus vy, which is equals to e to the power x into minus sin y minus cos y. Take that as equation number 2. Now we got a two equation ux, uy, vx, vy. Two equation but four unknowns. We can't find out the values. So with the help of the CR equation ux equals to vy and vx equals to minus uy, convert that four unknowns in terms of two unknowns. So that two unknowns, two equation, easily we can find out the values of the unknowns. So that the equation number 2 can be written as minus vx minus ux, which is equals to e to the power x into sin y plus cos y. We can write that as ux plus vx, which is equals to e to the power x into sin y plus cos y, because here negative sign will get cancelled both the side. Take this as equation number 3. Now you just solve this equation number 1 and equation number 3. That is ux minus vx, which is equals to e to the power x into cos y minus e to the power x into sin y. Ux plus vx can be written as e, which is equals to e to the power x cos y plus e to the power x into sin y. You just change the sign so that ux term will get cancelled. So minus 2vx, which is equals to 2e to the power x into sin y. 2 will get cancelled and vx can be written as e to the power x into sin y. So now we got the value of vx. With the help of this vx, easily we can find out the value of ux also. So ux minus e to the power x into sin y, which is equals to e power x cos y minus e to the power x into sin y. One term will get cancelled. So the value of ux is e to the power x into cos y. Now we got both the value ux and vx. So you just substitute this in the derivative formula of analytic function, that is f dash of z, which is equals to ux plus I into vx. Both the value we have to substitute and put x equals to z and y equals to 0. So we are getting f dash of z as e to the power z. On integration with respect to z, we can write f of z is equals to integration of e power z with respect to z plus c. So f of z will be e to the power z plus c. This is what our required solution. So now we got the required analytic function also. Now we'll see the next problem. If f of z, f of z is regular function of z, show that some result they given here, dou by dou x of modulus of f of z whole square plus dou by dou y of modulus of f of z that whole square, which is equals to modulus of f dash of z whole square. So they given this result, we have to prove that now. By taking LHS part, we have to prove the result in the RHS part. Given data is what? F of z is a regular function. Regular means it is an analytic function. So first f of z is regular, it means analytic. So modulus of f of z can be written as square root of u square plus v square. You just take that as a 5. So that we have to prove that dou phi by dou x whole square plus dou phi by dou y whole square, which is equals to modulus of f dash of z that whole square. That is 5x whole square plus 5y whole square, which is equals to modulus of f dash of z whole square. Let phi is nothing but square root of u square plus v square. So phi square is nothing but u square plus v square. Take this as equation number 1. You just do the differentiation is with respect to x. So 2 phi x can be written as 2u ux plus 2v vx. Take this as equation number 2. Again, differentiating with respect to y means we can write that equation number 1 has 2 phi y which is equals to 2u uy plus 2v vy. Take this as equation number 3. Now you just squaring and adding that equation number 2 and 3. So 4 phi square phi x square plus 4 phi square phi y square which is equals to 2u ux plus 2v vx that whole square plus 2u uy plus 2v vy that whole square. Now in LHS side 4 phi square, for if you taken as common means phi x square plus phi y square which is equals to 4 into here a plus b whole square and a plus b whole square formula we have to use. On expansion we can take that 4 as common in each and every term. That term we have to take and you just go for using these ER equations. Ux equals to Vy and Vx equals to minus Vy minus Uy. That two result you just substitute in a previous equation so that equation can be written as 4 phi square phi x square plus phi y square which is equals to 4 into u square ux square plus v square vx square plus 2uv ux vx plus u square into minus vx square plus v square ux square minus 2uv ux into vx. Like this we can write here 4 term we can cancel in both the side. So which is equal here after cancelling that here phi square into phi x square plus phi y square which is equals to u square plus v square into ux square plus uvx square. So phi square into phi x square plus phi y square can be written as 4 into phi square and ux square plus vx square. Here we can cancel that 4 and then phi square, both the term we can cancel that. The obtained solution, the rest of the term can be written as phi x square plus phi y square which is equals to ux square plus vx square. Take this as equation number 4. Already we know that f dash of z is nothing but ux plus I into vx. If you taking modulus means we can write modulus of f dash of z as square root of ux square plus vx square. Modulus of f dash of z square which is equals to ux square plus vx square. Take that as equation number 5. Equating that equation 1 and then equation 5. We can write that as phi x square plus phi y square which is equals to modulus of f dash of z that whole square. This implies dou by dou x of modulus of f of z whole square plus dou by dou y of modulus of f of z whole square which is equals to modulus of f dash of z whole square. This is what they asked us to prove the result. Now we prove that result. Now we'll see the next problem. If phi of x comma y is a differentiable function and f of z is u plus iv, u and v is a function of x and y, is a regular function. Now we have to prove that phi x whole square phi y square which is equals to phi u square plus phi v square that into modulus of f dash of z whole square. This result we have to prove that. Here to prove this you just treat phi as a composite function, treating phi to be a function of u and v and u and v is a function of x and y. With the help of this chain rule we can define that dou phi by dou x has dou phi by dou u by dou x plus dou phi by dou v by dou x. In terms of suffix if you return means phi x equals to phi u ux plus phi v vx and dou phi by dou y can be written as dou phi by dou u by dou y plus dou phi by dou v by dou y. That implies phi y which is equals to phi u uy plus phi v vy. Therefore, phi x square plus phi y square can be written as phi u into ux plus phi v into vx that whole square plus phi u into uy plus phi v into vy that whole square. Now you just do the simplification with the help of a plus b whole square formula. If you expand with the help of that formula means that this equation can be written as phi x whole square plus phi y square which is equals to 5u square ux square plus 5v square vx square plus 2 5u ux 5v vx plus 5u square uy square plus 5v square vy square plus 2 into 5u uy 5v vy. And with the help of that CR equation ux equals to vy and vx equals to minus uy, the above equation we have to do the simplification. So two terms will get cancelled. After doing the simplification, we can write this as 5x square plus 5y square, which is equals to 5u square plus 5v square, that into ux square plus vx square. Take this as equation number 1. And f dash of z is nothing but ux plus I into vx. If you go for taking modulus, means we can write that as square root of ux square plus vx square. Therefore, modulus of f dash of z whole square is nothing but ux square plus vx square. This result you just substitute in equation number 1 so that we can get the required result, that is dou phi by dou x whole square plus dou phi by dou y whole square, which is equals to dou phi by dou u whole square plus dou phi by dou v whole square, that into modulus of f dash of z whole square. This is what our required result. Thank you.